Okay, so thanks for joining me for your review for your quiz this Friday. I will do two videos, and there'll be a lot of writing, so just be prepared. But we'll do some conditional statements, some converses, biconditionals. We'll look at the postulates, and then at those two laws, the law of detachment and the law of syllogism. Okay, so our first problem here, I'm going to write a sentence. It says, a student on the honor roll has at least a 90% average. Okay, so this is the statement, and what I want is I want it to be written in an if-then form. Okay, I want the conditional. So it says a student on the honor roll has at least a 90% average. So there's no if in the sentence, so we're going to start left to right. The conditional, if a student, so if a student is on the honor roll, then, and you could put he or she, we'll put he has at least a 90% average. Okay, and again we went left to right. If a student is on the honor roll, then he has at least a 90% average. Remember these two words. The hypothesis is what comes after the if. So a student is on the honor roll. That is the hypothesis of the conditional statement. Then the words coming at the end, after then, he has at least a 90% average. This is called the conclusion. Okay, so remember those words. Now what happens if I want the converse? Okay, so let's write the converse now. CV for converse. The converse is just where you flip-flop the hypothesis and conclusion. So it says, if a student has at least a 90% average, then, and again you put he or she, then he is on the honor roll. Okay, there's the converse. So again, you flip-flop the hypothesis and the conclusion. And now, this must be some rule out of school, and because this rule is a rule, these are both true statements. So if they're both true, remember we can write what's called a biconditional. The biconditional, I like to go from the conditional. You take out the if-then part and start left to right. So a student is on the honor roll, and we take out the then and we put those four keywords if and only if. If and only if he has at least a 90% average. Okay, so there would be the conditional, the converse, and then since both are true, we have a biconditional. And again, let's remember the words hypothesis and conclusion. Hypothesis is the first part of a conditional statement. The conclusion is the second part. Okay, so here's problem one. Okay, now let's look at a second problem. Again, I will write a phrase. This phrase is if. So it's going to be a conditional. If the measure of angle P equals 45 degrees, then angle P is acute. Okay, and of course this is true because we know acute means less than 90. degrees, so it is true. So I want the converse. So again, we're just going to flip-flop the hypothesis and conclusion. If angle P is acute, then the measure of angle P equals 45 degrees. And now the question is, does this have to be true? Does this have to always be true? If angle P is acute, does it have to be 45 degrees? And the answer is no. So this is false. So what we need to show is a counterexample. And in this problem, the counterexample could be an acute angle, angle P, that is not 45 degrees. So let's draw this angle right here. Okay, here's angle P. If it's named by one letter, that's just the vertex, angle P. And I'm going to say that this angle is 25 degrees. So here's my counterexample. It's an acute angle, but the measure is not 45, it's 25 degrees. So be aware of counterexamples. Okay, and then the last one I have for here is over the postulates. Okay, we need to remember those 7 postulates. Okay, don't forget those. So let's do 2 here, and what we're going to do is we're going to sketch a picture that represents each postulate. So the first postulate we're going to look at is through any 3 non-collinear points, non-collinear points, there is one plane. There is exactly one plane. Okay? So remember that word non-collinear. They can't be on the same line. Very important, as we discussed in class. You can have an infinitely many number of planes going through collinear points. But if they're non-collinear, only one. So let's start with 3 points. Just call them A, B, and C. And again, it's important that they are not on, but they cannot be drawn on the same line. And these obviously are not collinear. And then we just draw a plane around them. I would like to give the plane a name. Let's call it plane Q. And there's your picture. 3, non-collinear points on plane Q. Okay, and let's do a 4th example, another postulate example. If 2 lines intersect, then their intersection is a point. Alright. So again, we have to show this picture. We have to show a description of this. So let's draw 2 lines. There's one. Remember, lines have arrows at the end. Let's call this just line L. Here's another line. Let's call this line M. And here is the point where they intersect. Call it point P. And there's a picture of 2 lines intersecting and a point. So if 2 lines intersect, then their intersection is a point. Okay, so please stay tuned for video 2 to prepare you for your quiz.